Imagine our Earth, but bigger, much bigger. We're talking twice the diameter, maybe even 10 times the mass. These colossal planets called super-Earths are more than just science fiction. They're real, orbiting distant stars across the galaxy. Super-Earths intrigue us. They make us ask, what if our planet had been born bigger? How would life, oceans, even mountains be different? Would we even exist? These aren't just academic questions. By studying super-Earths, we gain a new perspective on our own planet. We learn about the delicate balance of forces that make Earth the perfect haven for life as we know it. And we begin to imagine the incredible diversity of worlds that might exist beyond our solar system. Let's embark on a journey to a super-Earth, a world both familiar and profoundly different from our own. Let's explore the challenges and wonders of life on a giant planet. Step onto a super-Earth and you'll immediately feel the difference: gravity. With a more massive planet pulling you down, you'd be heavier. Maybe twice as heavy, maybe more. Imagine the strain on your bones and muscles. Animals would evolve differently too. Creatures might be shorter and stockier, built to withstand the increased gravitational pull. Trees might be shorter and wider, their branches needing extra support. Even the air would feel thicker, denser. Each breath would require more effort. The very act of living on a super-Earth would be a constant workout. But there's more to gravity than just weight. It affects everything from the flow of water to the formation of mountains, shaping the entire planet. On a super-Earth, gravity's impact on landscapes would be profound. Mountains, formed by the collision of tectonic plates, would face a tougher battle against gravity's pull. They might rise less dramatically, their peaks lower and broader. Erosion, driven by wind and water, would also be more intense, carving deeper valleys and canyons. Imagine vast plains stretching across continents, sculpted by the relentless forces of gravity and erosion. Rivers carrying heavier sediment loads would carve wider, shallower channels. The entire landscape would be a testament to the power of gravity on a supersized world. But the impact of a super-Earth's gravity wouldn't stop there. It would reach deep into the planet's core, influencing its geology and even its magnetic field. Oceans on a super-Earth would be a sight to behold. The increased gravity would pull more water onto the planet's surface, potentially creating deeper, more expansive oceans. Imagine vast, deep-sea trenches plunging miles beneath the waves. Ocean currents driven by wind and the planet's rotation would be affected too. They might be slower and more powerful, influencing weather patterns and marine life in unexpected ways. The pressure at the bottom of these super oceans would be immense, crushing to anything not adapted to survive it. Yet, even in these extreme environments, life might find a way. Imagine bioluminescent creatures illuminating the abyss, their bodies adapted to withstand the crushing pressure. Super-Earths could harbor an astonishing diversity of marine life, pushing the boundaries of what we thought possible. Look up at the sky of a super-Earth, and you'd see a tapestry of weather patterns unlike anything on our planet. The thicker atmosphere, combined with stronger gravity, would create a more stable climate, resistant to rapid changes. But stable doesn't mean boring. Imagine colossal storms, fueled by the planet's heat and the churning atmosphere, raging for centuries. These superstorms could span entire continents, dwarfing even the largest hurricanes on Earth. The composition of the atmosphere would also play a role. A super-Earth with a thick carbon dioxide atmosphere might experience a runaway greenhouse effect, leading to extremely high temperatures. On the other hand, a planet with a nitrogen-rich atmosphere might be much colder. Predicting the exact weather patterns on a super-Earth is a challenge. But one thing is certain, the skies of these giant worlds would be a dynamic and awe-inspiring spectacle. Could life thrive on a super-Earth? The challenges are significant, but life is incredibly adaptable. Imagine plants with incredibly strong root systems, anchoring them against the stronger winds and heavier rainfall. Animals might evolve denser bone structures and more powerful muscles to cope with the increased gravity. Flying creatures would need larger wingspans or more efficient metabolisms to power their flight. The very definition of habitable zone might need to be rewritten for super-Earths. A planet further from its star might still be warm enough for liquid water thanks to a thicker atmosphere trapping heat. Life on a super-Earth would be different, shaped by the unique challenges and opportunities of a high-gravity world, but it would be life nonetheless, a testament to the incredible resilience and diversity of nature. Launching a rocket into space from a super-Earth would be a monumental task. The escape velocity, the speed needed to break free from the planet's gravitational pull, would be significantly higher. Rockets would need to be much larger and more powerful, requiring vast amounts of fuel. The cost and complexity of space travel would be exponentially greater. But the challenges wouldn't end there. Once in space, spacecraft would need to contend with the super-Earth's stronger gravitational influence, making navigation and orbital maneuvers more difficult. Despite these obstacles, the dream of exploring the cosmos wouldn't be extinguished. Perhaps civilizations on a super-Earth would develop new technologies, harnessing the very forces of gravity to power their spacecraft. Discovering a super-Earth teeming with life would revolutionize our understanding of the universe. Many of our scientific models based on observations from our own solar system would need to be revised. The laws of physics would remain the same, but their application would be different in a high-gravity environment. We'd need to rethink our understanding of planetary formation, atmospheric dynamics, and even the evolution of life itself. Imagine textbooks being rewritten, scientific conferences buzzing with excitement, and a new generation of scientists inspired by the discoveries made on super-Earths. The study of these giant worlds would push the boundaries of human knowledge, opening up new frontiers in astrophysics, biology, and countless other fields. Super-Earths remind us that our planet is just one small world in a vast and diverse universe. They challenge us to expand our definition of habitable and to consider the possibility of life as we don't know it. By studying these distant worlds, we gain a new appreciation for the delicate balance of conditions that make Earth so special. We learn about the interconnectedness of gravity, geology, and life itself. Most importantly, super-Earths ignite our curiosity, reminding us that there's still so much to discover beyond our own pale blue dot. They inspire us to keep exploring, to keep asking questions, and to keep searching for answers among the stars.